Good morning, everyone. So today we're going to be doing part B on section 6.5, day 1. And we're going to be using trig to find angle measurements. So remember, whenever you're finding an angle measurement, you're going to have to hit second first, and then you're going to hit either sine, cosine, or tangent, depending on the problem setup. Okay. So in this first warm-up problem, we have Dan, and he's walking through the forest when he came upon a sizable tree. He estimated that he was 40 meters away from the tree. So here's Dan, here's the tree. Let me focus that. There we go. So here's Dan, here's the tree. So that's where we're going to put 40 meters on the bottom. And then they also said that he measured the angle of elevation between the horizontal and the top of the tree to be 35 degrees. So here's the horizontal, here's the top of the tree. So the angle of elevation between the horizontal to the top is going to be that 35 degrees. I'm not sure why this keeps losing focus. Sorry, guys. Okay, so now, if Dan is about 2 meters tall, about how tall is the tree? So here's Dan, he is 2 meters tall. So we want to figure out how tall the tree is. This is what our end goal is. However, all we can find is this part of the triangle, which is part of the height. If we were to find that height, then we could simply just tack on that 2 meters, and we can figure out how tall the tree is in total. So first, let's find the height of the triangle. Now, because we're finding a side length, we are not going to be hitting second. We're just going to be doing regular trig. So for side lengths, we do regular trig. All right, so here's the angle of reference. X is the opposite side. 40 meters is the adjacent side. So we're going to be doing SOHCAHTOA. We're going to be doing opposite over adjacent, that's tan. So tan of the angle is 35 degrees equals x over 40. Put tan over 1, cross multiply, and solve. So x is going to equal 40 tan of 35 degrees. Let's go into our calculator and see what that comes out to be. 40 tan 35 degrees. And we get that x equals 28.008. So let's round all of these to one decimal place. So that's just going to be 28 meters. But again, that represents the height of the triangle, not the height of the tree. So we have to also tack on that 2 meters. And to do that, you simply add. So you need to add x plus 2, which is 28 plus 2, to get that the tree is approximately 30 meters tall. Now, let's move on to part B of that problem. Dan was pretty impressed with this tree until he turned around and saw a bigger tree. So here was the initial tree, here's the larger tree. And that tree is also 40 meters away, but in the other direction. So let's put 40 meters on the bottom there. He's 40 meters from the other tree. And he said, well, I bet that tree is at least 50 meters tall. And then he thought, if it's 50 meters tall, I wonder what the angle of elevation I would measure from my eye level to the top of the tree be. So what is the angle of elevation if the tree is 50 meters tall? So we don't know what the tree is, but we're assuming that it is. So he's saying if the tree is 50 meters tall, he wants to find the angle of elevation. Well, the angle of elevation is always from the horizontal to the incline to the top of the tree. So we're trying to find that angle. Let's call it theta. So now, because we're finding an angle, so to find an angle, you do inverse trig. An inverse trig is just where you have either sine, cosine, tangent to the -1 exponent is what it looks like on your calculator. So you're going to have to hit the second button first. All right, so again, we are going to be doing opposite over hypotenuse, right? But the tree is not the height of the triangle. The tree's height is the height of the triangle plus that 2 meters that we said he was. We said he was 2 meters tall. So therefore, if x plus 2 equals 50, that means that the height of the triangle is really 50 minus 2. That's going to be 48. So let's erase that. And let's put 48 on our on the height of our triangle. So that's your opposite. 48 is your opposite, and 40 is your adjacent. And now we're going to do tan. Opposite of adjacent is tan, so tan inverse of 48 opposite over adjacent, and that's going to give you what theta is. So you're just typing that into your calculator. Second tan, and that was 48 over 40. And that comes out to be 50.19. Let's call that 50.2 degrees. So the angle of elevation is 50.2 degrees. Next, let's move on to our next problem that we want to do, and that's going to be this problem number 3 here on the notes packet that I'm posting as well as a PDF. Okay, so we have a 16-foot ladder leaning against a wall. So here is the wall, and the ladder is leaning against the wall. So here's the ladder. And I'm going to also draw on the ground. Okay. So now we know that the foot of the ladder, the foot is always the bottom. So the bottom of the ladder is 7 feet from the wall. So bottom of the ladder to the wall, 7 feet. And we want to find the vertical distance from the ground. Oops, we also forgot to label something. That the ladder was 16 feet. So this is the ladder. Let's put 16 feet on that. Vertical and horizontal make a right angle. Now they want us to find the vertical distance from the ground. So vertical is up and down. From the ground to the point where the top of the ladder touches the wall. So they want us to find the height of the triangle, the vertical distance from the ground to the top of the ladder. Okay, well, what do we have here? We have a right triangle with 2 sides given, 1 side missing. Well, this is a blast from the past. How else can you find the missing side of a right triangle if you know 2 of them? Pythagorean theorem. And Pythagorean theorem says a squared plus b squared equals c squared, whereas a, b, and c are side lengths, but c is the special side length called the hypotenuse. And the hypotenuse is always across from the right angle. All right. So now let's do Pythagorean theorem. Which one is our hypotenuse? There's the right angle. So that is going to be C. So we do x squared plus 7 squared equals 16 squared. X squared plus 7 squared I know is 49, but let's do on our calculator what 16 squared is. So that comes out to be 256. Okay, so now we got to get x squared by itself, so I subtract 49 from both sides. So 256 minus 49 comes out to 207. And then last but not least, I need to square root both sides. So I know it's going to be the square root of 207. And let's see what that approximation is. When we type it into our calculator, square root second, the square button gives you the square root, 207. So that's going to be approximately 14.4, and I believe it's feet, yes. All right, which makes sense because the hypotenuse has to be the longest side. All right, so now let's determine the measure of the angle that is formed by the ladder and the ground. So let's honestly just look at this picture here again. Get this straight for you guys. So we want the angle formed by the ladder and the ground. The ladder, ground is right here. So we want that angle of elevation. So I'm going to redraw that triangle quickly. Not with the same artistic ability as that one though. And now I had 16 here, 7 here, and I just found that was square root of 207. Now, we have all the side lengths, so it doesn't matter which one we use to find the angle, but I would suggest using the ones that were given to you because that way if you made a mistake on this side, you're not going to get the wrong answer again. So use the ones that were given to you. This is the hypotenuse, and this is the adjacent. So then we should be using cosine. So we're going to be doing inverse cosine since we're finding the angle measure. Inverse cosine is adjacent over hypotenuse, so 7 over 16 equals theta. Type that into our calculator. Second, cosine 7 divided by 16. Oh, it froze. Give me a second here so I can restart it. Divided by 16. Perfect. And we got 64.055. So 64.055. Now on these, they actually gave instructions as to what to round to. They wanted it to the nearest hundredth of a degree. The hundredths place is 2 decimal places. So that means you have to look all the way to the third decimal to see whether you round up or down. So it's 0.55. The third decimal place is a 5, which means you round up to get 64.06 degrees for theta. All right, last problem is going to be problem number 4. Once we are focused, there we go. Okay, so we have a group of friends and they have hiked to the top of the mile-high mountain. Well, it gets its name from its actual measurement. It's a mile high. So here's a mountain, it's a mile high. So 1 mile goes on the top, and they hiked to the top of it. So they went all the way up to the top of the mountain. Okay, when they look down, they can see their campsite, which they know is approximately 3 miles from the base of the mountain. So here's the base of the mountain. This is going to be the campsite. We'll call it C. So they know that that's approximately 3 miles from the base to the campsite. And now they want us to find the angle of depression, and we're going to round to the nearest hundredths again, so 2 decimal places. They want the angle of depression. Well, the angle of depression is always from the horizontal going down. So here's the horizontal, here's you going down. So that is your theta. But remember, horizontal lines like these two are always parallel, right? So then this is your transversal. So if we were to look at this, parallel, parallel, transversal, then this angle and this angle are alternate interiors, making them congruent. So if that is your angle of depression, it is equivalent to your angle of elevation. So we could just look at this theta here. So if theta is our reference angle, that's our opposite side. This is our adjacent side. So we're going to be doing tan inverse of 1/3, opposite over adjacent equals your theta. And let's type that into our calculator. Second, tan 1 divided by 3. And you get 18.434. So because the third decimal place is 4, that's less than 5, we're going to round down, so we're going to keep it at the 3. So 18.43 degrees is your angle of depression. All right, and that's all. The rest of this is going to be, well, not the rest. Most of these problems that are quicker are going to be put into a Google form, and those are going to be your homeworks. So you are welcome to start working on that. As always, please sign up for office hours if you have any questions, or email us. Take care. Hope you're all doing well. Thanks. Bye.